Hello and welcome everyone. We're going to work on a little bit of circuit stuff. We're doing mesh analysis for DC circuits. It's probably the first and maybe most popular network theorem that you'll come across in the early stages of your physics or engineering education. So there's three steps. First one is to assign a current in the clockwise direction for each loop. The second one, indicate the polarities for each resistor. And number three, apply KVL for each loop. So we'll do a quick example and you'll see that it's very simple once you get the hang of it. Maybe a little bit of a learning curve, but nothing too major. It should be quite intuitive and something that once you figure this out, you should be able to do just about any mesh problem. So for starters, we'll take our first rule. We'll assign a current to each loop. So loop number one, right here, I1. Loop number two, I2. And like I said, go clockwise. You can go counterclockwise if you'd like. It's there's nothing wrong with that. As long as you're consistent, it should work out to be the same. But most books try to do it this way, and your professor will likely do it this way. So you might as well try to stay consistent. So let's put our polarities as step number two. We know that this voltage, where the longer end is there, it's plus here, minus. So then the way to think about the resistors is when the current is going through this little wire, it should be entering your positive portion of the resistor and exiting the negative portion. Okay, so go around. This is a plus and a minus. That's voltage, and then this resistor, it's coming down. Okay, and where it's coming down, we know that it is a plus entrance and a negative exit. Now you can use any point to start and finish the loop. It doesn't matter which point you start at / finish at. You should get the same results. So let's do loop number two now. So we'll start from this corner. This resistor right here, we enter, so plus, and exit minus. You'll notice that these signs are all conflicting. It looks a little bit odd, but you'll see why in a couple minutes. So we have the voltage source remains the same. Go around. We enter into the resistor, exit with a negative, and we get a plus and a minus for those directions. So let's go loop one and loop two. Okay? Let's lay out exactly what we have in each of these loops. So this is where we do our KVL. We'll start from here. We'll begin with a negative E1. So the reason why these numbers will be positive or negative, it really depends on where you're exiting, right? That's a good way to keep track of it. When you're following this current along, you're exiting out the negative end. It may not be the most appropriate way to think about it, but it's the way I always remembered when it came to putting that sign down. So it exits out of the negative portion, and we get to this, which will be negative I1 because it's in the I1 loop, and R1 is our resistor. So as you can see, that's Ohm's law right there. That's a voltage. So that should make sense. As we come around, we get to our next voltage, which is E2. We exit over the negative portion, so negative E2. And we continue down, and we get to this resistor. So at this resistor, we're going to do the same as what we did for R1. So we'll go I1, R2. And what we're also going to do is, because this is shared by both sides, we're going to go plus I2, R2 equals 0. Okay? and it's equal 0 because we're at the end of our loop. But you need, this is maybe the most important part of mesh analysis. If you remember to do this correctly, then you shouldn't have any issues. So let's do loop number 2, and we'll encounter this once again, and you'll see how it is similar yet differentiates a little bit. So we'll start from this corner. We'll go minus I2 R2, okay? So it's a negative this time because we're using that second loop. And then we go plus I1 R2. So it's the exact opposite of what we have here. I hope that makes sense, because that is maybe the most essential part of mesh analysis when it comes to getting that answer right. So then we have plus E2, and I'm going to speed through the rest of these a little bit, minus I2 R3, and minus E3 equals 0. Okay, so we'll put some numbers here. We've got, well, actually, let's put E1 and E2 on the other side. So E1 plus E2, okay, where they're both negatives, I'm just putting them on the other side, become positive. And then we have, I might clean this up a little bit, minus I1, okay, we have an I1 here and an I1 here. So I'm going to go R1 plus R2. You don't have to do this, but it does make it a little bit nicer to look at. And then plus I2 R2. Okay, that's that last value there. Same thing here. Put the voltage to the other side. So we'll have E2, we'll have E3 minus E2. And we will have minus I2 is right there and right there. So we'll go R2 plus R3. And what else do we have here? We have a I1 R2. Okay. So order of these shouldn't matter too much at this stage. Now let's put our values in. So let's make a little bit of a matrix here. Loop 1, loop, oh, here I'll move that up. Loop 2. And we have negative I1 times R1 plus R2. So R1 is 3 ohms, and R2 is 4 ohms. So that'll give us 7 ohms right here, okay? And then what do we have for I2? I2 times R2, which we just said was 4 ohms. And that equals E1, which is, what's E1? That's 6. And E2, which is, let's see, 5. So that gives us 11 volts. Okay, I hope everyone's following along up until this point. Might be getting a little bit messy, but so loop number 2, we'll go, we have an I1 times R2, which is 4 ohms, and then minus I2 times R2 plus R3. So R2 gives us 4 ohms, plus R3 is 6 ohms, okay? So 10 ohms equals, and then what do we have for E3? E3 is 6 volts minus E2, which is 5 volts. So that'll give us 1 volt. Okay? So usually at this point, you can leave this the way it is. Most professors don't get too picky on this. However, you can solve this. You can solve it as a matrix, basically. There's many mathematical methods to doing it. The easiest being plugging it into MATLAB or Wolfram Alpha or your calculator. However, this is quite a simple one, but maybe I'll solve that in another video just to save some time. Anyways, hope this was helpful, and I'm probably going to make a couple more of these videos before I make my burgers and have some supper. Okay, great.